Hello student, here is the question that two long wire carrying current 8 ampere and 6 ampere along x-axis y-axis respectively. So here is the two current carrying wire which you have, that's along the x-axis and along the y-axis. One is along the x-axis and another is along the y-axis. So here is the first wire and second wire is this one. So here is along the y-axis. Here is the wire along the y-axis. Now, magnetic field at a point, that's point, let's say that's the origin, okay, that's the origin, and here is the point 2i cap, you can say that's a 2i cap and 4j cap, so point will be here, okay, 2i cap and 4j cap, let's say 2i cap, here is the 2, comma 4. Now the magnetic field at that point will be, so you have to calculate the magnetic field at that point. So magnetic field at that point can be written as, here is the current is flowing in this wire, that's equal to along the x-axis, so current is 8 ampere, and another wire that's along the y-axis, its current is 6 ampere. So just put the values over, magnetic field will be equal to at that point, let's say that point is P, okay. So magnetic field at that point due to I1, that's the first wire and that's the second wire, due to first wire that will be equal to B1 vector, and due to second that's equal to B2 vector, okay. So just put the values of B1 vector, so here B1 vector will be equal to current is flowing like that, okay. So at point, this point is along this one, okay. So magnetic field will be current in this direction, just spread your fingers towards the point. So whatever the direction you are palm direction you are getting, that is the direction of magnetic field, okay. Right hand palm rule I'm using. So here current is in this direction, spread your fingers in the direction of magnetic, in the direction of the point, you will get the direction of palm, which will be the direction of magnetic field, okay. So it is coming out to be out, okay. So you can see it's coming out to be out. So here you will write that's magnetic field due to infinite wire, mu naught into I1 upon 2 pi r, and the distance of that perpendicular distance of that point from the wire, that's equal to 4, okay. So here you can put the value mu naught into I upon 2 pi r, okay, and direction is out, plus due to B, due to 2, you can see that current is flowing like that. You spread your fingers towards the point, you will get the direction of the palm inward into the plane. So here mu naught into I2 upon 4 pi, perpendicular distance of that point from the wire, that's equal to 2, 4 upon 2 pi r into 2, okay. So it is into the plane. So you can see from here that's coming out to be 8 or that's coming out to be 4, and here you just calculate the values, that's the mu naught, okay. So just put the values of mu naught here, mu naught 4 pi 10 raised to power minus 7, the current I1 that's equal to 8 upon 2 pi into 4, okay. So just cancel it out, 4 and 4 will cancel out, pi and pi will cancel out, you will get the 4, okay. So here is the 4 and out to the plane, plus put the value here, that's a 4 pi into 10 raised to power minus 7, current I2 that's equal to 6, and that's equal to 2 into 2, 4 pi, so that 4 pi will cancel out from that 4 pi, okay. So here is you can see this direction is into the plane. If I just reverse the direction of, so magnetic field net is coming out to be B is equal to 4 into 10 raised to power minus 7, into the plane, out to the plane, plus 6 into 10 raised to power minus 7 into the plane, okay. So you can say this quantity is more than that quantity, so just I'm just reversing that quantity. I can write it as, that's a minus 4 into 10 raised to power minus 7. If I am taking the minus sign, I am to reverse the direction, so it will be inward direction now, plus 6 into 10 raised to power minus 7 into the plane, okay. So just add it up, you will get the 2 into 10 raised to power 7 into the plane, okay. So magnetic field will be equal to 2 into 10 raised to power minus 7, and it matches with your option number 4. So option number 4 is the correct answer of this question, okay. Thank you.